Hey guys, and welcome back to another Dynamics Physics in the Flesh episode. This one on two hanging buckets. One 2.3 kilogram bucket is hanging by a massless cord from another 2.3 kilogram paint bucket, also hanging by a massless cord, as shown below. A. If the buckets are at rest, what is the tension in each cord? B. If the two buckets are pulled upward with an acceleration of 1.50 meters per second squared by the upper cord, calculate the tension in each cord. So this is a simple diagram we've been given in this problem, but regardless of how complex this problem may look, it's actually pretty straightforward if you break it up into simpler parts. Okay, now usually I draw the free body diagram first. I'm going to have to do two free body diagrams, one for each bucket. So I'm actually going to define my positive direction first, and I'm going to let positive be up, since that's usually the convention. Okay, next. I'm going to label my buckets because they look the same, but they've got slightly different forces acting on them. So I'm going to let the bottom one be 1 and the top one be 2. This way I can keep everything straight. Now, I'm going to start by drawing my free body diagrams. So I'm going to do that on the right. So here's my bucket 2, and let's see what forces I've got acting on it. Okay, so on bucket 2, I have a string up. It's sustaining its weight and the weight of the bucket below. I'm going to call that FT2 for F tension connected to bucket 2. Okay, now, of course, this bucket has a weight, so I'm going to call that FG2. And there's another string here that's holding up the bucket below it, but there's tension in that string, so I'm going to call that FT1. So there are all the forces acting on bucket 2. Now, you got to do the same thing for bucket 1. So here's my bucket 1. What forces are acting on bucket 1? Well, it's that same string. Okay, so I'm going to call that FT1. It has to be the same tension because it's the same string. And of course, I've got the weight due to bucket 1. Pardon me. FG1. Okay, now one of the keys to this problem is that the buckets are at rest. And as soon as you see at rest, you should be thinking acceleration equals 0, F net equals 0. Therefore, when you do F net equals ma, it works out very clean and very nice. Okay, so the first thing, I'm actually going to start with bucket 1 because it's a bit simpler. Usually you want to start with the F net equals ma of the item or the object that has less forces acting on it. Okay, so let's start with that. So we're going to do F net y for object 1. Okay, put that vector symbol on top, equals the mass of object 1 times ay, acceleration in the y direction. Now, the forces you have acting on this are Ft1 in the positive, Fg1 in the negative. Okay, so I'm going to go ahead and do Ft1 minus Fg1 equals, now m1 acceleration is 0 as we just stated over here because the system's at rest. Now, if that's 0, 0 times any number is 0, so that cancels out this expression. Okay. So now we're left with Ft1 minus Fg1 equals 0. So let's bring the Fg1 over to the right side, and we're going to bring Ft1 equals Fg1. Fg1 is simply the mass of 1 times g, so that's equal to m1 is 2.3 kilograms. They're the same. G is 9.8 newtons per kilogram. Okay, when you multiply those out, the kilograms cancel and you're left with 22.54 newtons. So Ft1 is equal to 23 newtons. Okay, so we've got tension in cord number 1. Now let's find tension in the second cord. Okay. So let's do that actually on another sheet because we're getting a little bit packed here. Actually, let's do this so you can still see the free body diagram. Okay, so we're going to do the same thing. We're going to say F net in the y direction for object 2 is equal to mass of object 2 times acceleration in the y. Okay, hopefully you already see where this is going. Okay, for object 2, we've got one force in the positive direction, Ft2, two forces in the negative direction, Ft1 and Fg1, or pardon me, Fg2. Okay, so let's do this minus that. Okay, so we've got Ft2 minus Ft1 minus Fg2 equals m2 times 0. Again, let me scroll that up now that we're done with the free body diagram. Anything times 0 is 0, so that disappears. Okay, so now let's bring over the two expressions on the on this half to the right side. So we're going to get Ft2 equals Ft1 plus Fg2. Okay, now we just found Ft1, it's 23 newtons. So you can see if you had started in this direction with this with object 2 first, you would have run into this and you would have had to stop and then solve for object 1, and then you would have plugged in the answer here. Since we already did that, I'm going to simply plug it in. Ft1 is 23 newtons. Okay, Fg is m2 times g. Okay, so 23 newtons plus 2.3 kilograms times 9.8 newtons per kilogram. Now, we already did this calculation, right, because it's the same weight paint bucket. So it should be 23 plus 23. So 23 newtons plus 23 newtons equals 46 newtons. So there is the tension in cord 2. So there's cord 2, cord 1 was 23 newtons, and there you have the answer for part A. Okay, now, on the one hand, that was seen to be the easier part, because in the next part, part B, we're actually accelerating, but it's actually not so bad. Okay, so let's take a look at part B again. Now the two buckets are pulled upward with an acceleration of 1.50 meters per second squared by the upper cord. Calculate the tension in each cord. Okay, now just think about it logically. If you're pulling, now if you're accelerating up, the tension in the cords should go up. Okay, it should increase. Okay, that makes sense logically. Now, the free body diagrams are the same. We still have tension 2, tension 1, gravity. The only difference is the magnitude of those forces are going to be a little different. Okay, so let's do part B now. Okay, so same FBDs, free body diagrams. This time with acceleration equal to 1.50 meters per second squared up. Okay, so we're going to solve it like this. Now, I'm going to start with object 1 again because that's the simpler one. So F net Y1 is equal to M1 AY. Okay, again, if you look at object 1, you've got tension minus Fg1. So you do Ft1 minus Fg1 equals M1 AY. The only difference between the previous step and this one is that here we don't set AY equal to 0. We just set it equal to 1.5. That's it. That's the only difference. Okay, we're solving for tension, so I'm going to do Ft1 equals Fg1, which is M1G plus M1 AY. Okay, let me grab another sheet there. Okay, now hopefully you can see that we're able to factor out the M1. So if we factor out M1, we get G plus AY. Okay, M1 is 2.3 kilograms. G is 9.8 newtons per kilogram. And AY is 1.50 meters per second squared. But remember, meters per second squared, newtons per kilogram, they're equivalent to each other, and there's a very simple calculation you can do to prove that. Okay, so when you solve this expression through, you're going to get Ft1 equals 26 newtons. Okay, that's a little bit larger than what we had before at 23 newtons. Okay, so that's for object 1. Let's go ahead and keep going. Do it for object 2. F net Y2 is equal to M2 AY. Okay, so remember, for object 2, there's a little bit more things going on. For object 2, we've got tension up, we've got Ft1 down, we've got Fg2 down. So let's go ahead and plug in our forces. So now we've got Ft2 minus Ft1 minus Fg2 equals M2 AY. Okay, isolate for Ft2 because that's what you're looking for. So Ft2 equals Ft1 plus M2G plus M2AY. Okay, so we know Ft1. Ft1 is 26 newtons. We just found that out. Okay, and notice here we've got two M2s. So we're going to take out M2, which is 2.3 kilograms. And you're left with G plus AY. So 9.8 newtons per kilogram plus 1.50 meters per second squared. Plug that all into your calculator and you're going to get 52 newtons. Okay? So there you have it. You've got FT2, you've got FT1 up here. And that's it for this video, guys. There are your tensions. You can see that they've clearly increased. I hope you enjoyed the video. If you did, be sure to click that like button and subscribe to my channel so you never miss a video from Physics in the Flesh. I post every weekday at 12 noon, so be sure to be on my channel at that time to catch my latest video. Enjoy the rest of your day, guys, and I will catch you in the next video.